Close your eyes now. Feel the soft weight of your blanket against your skin. The warmth of your pillow beneath your head. Everything around you feels solid and real. But tonight, you will discover a secret. A gentle secret that lives in the spaces between everything you touch. Your body is made of tiny building blocks called atoms. Billions and billions of them. Each one smaller than you could ever imagine. They dance together to make your skin, your bones, your beating heart. But here is the beautiful mystery. Every single one of these tiny dancers has a twin. A perfect mirror image waiting somewhere in the vast universe. Scientists call these mirror twins antimatter. And they are the most expensive substance that exists anywhere. Imagine looking into a still pond at twilight. You see your reflection staring back at you. Your antimatter twin is like that reflection. But instead of living in water, it lives in the hidden corners of space itself. When matter meets antimatter, something magical happens. They dance together for just one perfect moment. Then they disappear completely. They turn into pure light. Pure energy. The brightest flash you could ever imagine. This is not science fiction. This is real. This happens every day, all around you. Right now, as you breathe slowly in and out, tiny antimatter particles are floating down from space. They pass through your roof. Through your walls. Some even pass gently through your body without you feeling a thing. They come from exploding stars that died millions of years ago. They travel across the galaxy like invisible rain. Most of them are so small and so fast that they slip between your atoms like ghosts. But sometimes, very rarely, one of these antimatter visitors meets its perfect twin in your body. When this happens, they create the tiniest spark of light. Smaller than the smallest thing you can think of. But real. You are part of this cosmic dance right now. Matter and antimatter swirling around you in an ancient ballet. The story of antimatter begins with a brilliant scientist named Paul Dirac. He was working with numbers and equations in 1928. He discovered something strange in his calculations. Something that didn't make sense at first. His math was telling him that every particle should have an opposite. A twin with the same mass but opposite charge. Like a photograph and its negative. Other scientists thought this was impossible. How could matter have a perfect opposite? Where was this mysterious antimatter hiding? But Dirac trusted his equations. He believed that nature followed mathematical rules. Even when those rules seemed to point toward something invisible and strange. For years later, another scientist named Carl Anderson was studying cosmic rays. These are particles that shower down from space constantly. Anderson was watching their trails in a special detector filled with gas. One day, he saw something extraordinary. A particle track that curved the wrong way. It looked exactly like an electron, but it bent in the opposite direction. As if it had opposite charge. Anderson had found the first antimatter particle. He called it a positron. The positive twin of the negative electron. This discovery changed everything. It proved that Dirac was right. Every particle of matter really does have an antimatter twin waiting somewhere in the universe. Scientists began to search for more antimatter particles. They built powerful machines to create them. They discovered antiprotons, the opposites of protons. Antineutrons, the twins of neutrons. Each discovery was like finding a new piece of a cosmic puzzle. A puzzle that revealed the hidden mirror side of reality. But here is the strangest part of all. If every particle has an antimatter twin, where is all the antimatter? Why is our universe made almost entirely of matter? This is one of the deepest mysteries in all of science. Something called the antimatter puzzle. When the universe was born in the Big Bang, it should have created equal amounts of matter and antimatter. Like flipping a coin billions of times and getting heads and tails in equal numbers. But somehow, matter won. There was just a tiny bit more matter than antimatter. One extra matter particle for every billion pairs. All the antimatter disappeared in flashes of light. Only the leftover matter remained to build stars and planets anew. This tiny imbalance saved the universe. Without it, everything would have annihilated into pure energy. There would be no atoms, no molecules, no life. Just endless light spreading through empty space. You exist because of this ancient victory of matter over antimatter. You are made from the survivors of the greatest battle in cosmic history. But antimatter didn't disappear completely. It still hides in the shadows of our matter-filled world. Scientists have learned to capture it in magnetic traps. They create it in powerful particle accelerators underground. A single gram of antimatter contains more energy than the largest nuclear bomb ever built. But making even 1 gram would cost more money than exists on Earth. Antimatter is literally more valuable than anything else in the universe. Yet it surrounds you every day in tiny amounts. In cosmic rays. In radioactive decay. In the medical scanners that help doctors see inside your body. You are connected to antimatter right now. As you lie here in the darkness, cosmic antimatter is passing through you like a gentle, invisible breeze. Tonight, you will journey deeper into this hidden world. You will discover how antimatter forms in the hearts of dying stars. How it powers the most violent explosions in space. How it might one day carry humans to distant worlds. But for now, simply rest in this knowledge. You are part of something vast and mysterious and beautiful. The cosmic dance between matter and antimatter that began with the birth of time itself. As your breathing slows and your mind grows quiet, imagine the antimatter twins of your atoms scattered across the galaxy. Waiting patiently for the day when all matter returns to light. Tomorrow's chapter will carry you back to the very beginning, when the universe was young and matter and antimatter first opened their eyes to each other in the cosmic dawn. Let your mind travel back now. Far back through time. Before there were stars. Before there were planets. Before there was even space as you know it. Imagine a moment when the entire universe could fit in the palm of your hand. Smaller than small. Hotter than hot. Everything that would ever exist pressed into a single point of pure energy. This was the beginning. The Big Bang. Not an explosion in space, but the birth of space itself. In that first instant, time began its gentle tick. The universe started to stretch and grow like a balloon slowly filling with air. And in that stretching, something beautiful happened. Energy began to dance. The universe was so hot that matter could not exist yet. Only pure energy swirled in the cosmic darkness. But this energy was restless. It wanted to become something more. As the universe expanded and cooled, the energy began to slow down. Like a river that starts as a rushing torrent and gradually becomes a calm stream. And in this slowing, the first miracle occurred. Energy learned how to become matter. But here is the beautiful part. Energy is perfectly balanced. It follows rules as precise as music. When energy creates matter, it must also create antimatter. Always in equal amounts. Always in perfect pairs. Picture 2 ice skaters spinning together on a frozen pond. When they push apart, one spins clockwise and the other spins counterclockwise. The total spin remains 0. The universe stays balanced. This is how matter and antimatter were born. As perfect opposites. Each particle of matter paired with its antimatter twin. Each one spinning the opposite way in the cosmic dance. In those first tiny fractions of a second, the universe filled with pairs. Electrons and positrons. Protons and antiprotons. Neutrons and antineutrons. All dancing together in the warm, bright soup of creation. These particle pairs lived in perfect harmony. They swirled around each other like partners in a cosmic waltz. For a brief moment, matter and antimatter existed in equal numbers. The universe was a balanced scales. Matter on one side. Antimatter on the other. Everything in perfect equilibrium. But this balance was delicate. Matter and antimatter are like opposite magnets. When they touch, they cannot help but annihilate. They turn back into the pure energy from which they came. All around the young universe, these reunions were happening. Particle meeting antiparticle. Twin finding twin. Each meeting ended in a flash of light as they danced back into energy. For every billion particles of matter, there were a billion particles of antimatter. They found each other and disappeared in brilliant flashes. The universe glowed with the light of these cosmic reunions. This dance of annihilation continued as the universe grew older and cooler. Second by second, the population of particles shrank. Matter and antimatter were finding each other and returning to light. If this perfect balance had continued, the universe would have become empty. Nothing but light spreading through expanding space. No atoms to build stars. No molecules to create life. Just endless, gentle radiation growing dimmer as space stretched. But something broke the perfect symmetry. Some tiny, mysterious preference saved the universe from emptiness. For every billion pairs that found each other and vanished, one single particle of matter survived. Just one. A cosmic orphan left behind when its antimatter twin had already danced away with someone else. This tiny imbalance was smaller than you can imagine. Like having one extra grain of sand on a beach that stretches around the entire Earth. But it was enough. Those leftover particles of matter became everything. The stars that light up the night sky. The planets that orbit them. The atoms in your body. The air you breathe. You exist because of this ancient accident. This tiny breaking of the cosmic balance that happened when the universe was less than a second old. Scientists call this mystery the baryon asymmetry problem. It is one of the deepest questions in all of physics. Why did matter win over antimatter? What caused this slight preference for particles over antiparticles? Many ideas have been proposed. Perhaps the laws of physics have a tiny built-in bias toward matter. Maybe there were special particles in the early universe that decayed differently. Or perhaps the answer lies in dimensions we cannot even see. Some scientists think the answer might be hiding in neutrinos. These ghostly particles that barely interact with anything. They might hold the key to why you exist instead of pure light. Other researchers believe the answer lies in the behavior of particles called mesons. These unusual particles sometimes act differently from their antimatter twins. This difference is incredibly small, but it might have been enough to tip the cosmic scales. The truth is, we still do not know. The mystery of matter's victory remains unsolved. But astronomers have found clues scattered across the universe. They can see the afterglow of those ancient annihilations. When matter and antimatter met in the early universe, they created light. That light still travels through space today, cooled and stretched by billions of years of cosmic expansion. We call this light the cosmic microwave background. It surrounds us like a gentle whisper from the universe's childhood. When you tune a radio between stations and hear static, some of that static is this ancient light. The echo of creation itself. This background radiation tells us the story of those early moments. It shows us that matter and antimatter really did exist together in nearly equal amounts. And it confirms that something broke their perfect balance. In certain places in the universe today, scientists can still see matter and antimatter meeting. When cosmic rays hit the upper atmosphere, they sometimes create antimatter particles. These particles quickly find matter partners and annihilate in tiny flashes of gamma rays. Space telescopes can detect these flashes. They see them happening in the centers of galaxies where black holes tear matter apart. They see them in the remnants of exploded stars. Everywhere matter and antimatter still find each other, the universe lights up with their reunion. But most antimatter has been gone for nearly 14 billion years. It vanished in those first moments when the universe chose matter over its perfect opposite. The antimatter that remains is precious beyond measure. Each antiparticle that scientists create in their laboratories costs more than its weight in gold. More than diamonds. More than anything else humans have ever made. Yet in those first seconds of creation, antimatter filled half the universe. It was as common as matter itself. The universe was rich beyond imagining with the most expensive substance that exists. As you rest here tonight, you are made from the survivors of that ancient battle. Every atom in your body won a cosmic lottery that lasted less than a heartbeat. You are built from the matter that remained when its antimatter twins had danced away into light. In the next part of our journey, we will explore what happened to that missing antimatter, and discover why this ancient disappearing act saved not just matter, but the possibility of everything you see around you. Picture the universe as a vast theater, dark and quiet. On this cosmic stage, the greatest magic trick of all time is about to unfold. You have the best seat in the house, watching from the gentle darkness of your bedroom. The curtain rises on a universe barely 1 second old. The stage fills with countless dancers. Matter particles spinning in one direction. Antimatter particles spinning the other way. Perfect partners in an endless ballet. For every proton, there dances an antiproton. For every electron, a positron pirouettes nearby. The cosmic stage overflows with these pairs, each one waiting for its moment to reunite. Then the music begins. Not sound, but the deep rhythm of physical laws. The tempo that governs how particles move through space and time. One by one, the dancers find their partners. Matter meets antimatter in embrace after embrace. Each reunion ends the same way. A flash of pure light. A return to the energy from which they came. The stage begins to empty. Billion by billion, the dancers disappear in brilliant flashes. The universe grows quieter with each passing moment. But watch carefully now. Something strange is happening in this cosmic dance. For every billion pairs that find each other and vanish, one dancer is left without a partner. One particle of matter stands alone. This is the gentlest of magic tricks. So subtle you might miss it if you blink. A preference so small it barely exists. Yet it changes everything. The magic lies in symmetry breaking. Imagine a perfectly balanced pencil standing on its tip. For a moment, it could fall either way. Then the slightest breath of air decides its fate. It tumbles to one side. In the early universe, the laws of physics were like that balanced pencil. They could have favored matter or antimatter equally. But some invisible breath tipped the scales toward matter. Scientists have names for the forces behind this cosmic magic trick. CP violation. Baryon number violation. Leptogenesis. These words sound complex, but they describe something beautifully simple. They describe how the universe learned to be slightly unfair. This unfairness was tiny beyond imagination. If the universe created 10 billion antimatter particles, it created 10 billion and 1 matter particles. Just one extra particle out of every 10 billion. But in a universe filled with trillions upon trillions of particles, this tiny bias added up. Like drops of water eventually filling an ocean. As the cosmic dance continued, all the perfectly matched pairs disappeared into light. Only the lonely matter particles remained. The cosmic orphans. The survivors of the greatest vanishing act ever performed. These leftover particles cooled as the universe expanded. They began to find each other and stick together. Protons and neutrons hugged close to form the first atomic nuclei. Electrons danced around these nuclei to create the first atoms. From the survivors came hydrogen. The simplest and most abundant element in the universe. Light, clean hydrogen that would later gather into clouds and collapse to birth the first stars. From those stars came all the heavier elements. Carbon forged in stellar cores. Oxygen breathed out by dying giants. Iron hammered in the hearts of the most massive stars. Every element in your body was created by matter that survived the great vanishing. The calcium in your bones. The iron in your blood. The oxygen you breathe right now. You are made from ancient survivors. Cosmic refugees from the early universe who escaped annihilation by the narrowest of margins. But why did this happen? What caused the universe to prefer matter over antimatter? This question keeps scientists awake at night, wondering about the deepest secrets of existence. Some think the answer lies in particles so strange they barely interact with normal matter. Particles that existed only in the universe's first moments. They might have decayed in ways that created slightly more matter than antimatter. Others believe the answer hides in extra dimensions. Spaces beyond the 3 dimensions you can see. In these hidden dimensions, the laws of physics might work differently. They might naturally favor matter over its opposite. Still others think the answer involves time itself. Perhaps time has a direction that naturally points toward matter. A cosmic arrow that guided the universe's choice in those crucial early seconds. The truth is, we are still watching this magic trick unfold. Still trying to understand how the cosmic magician performed the greatest sleight of hand in history. Modern experiments try to recreate those early conditions. Scientists smash particles together at incredible speeds. They create tiny amounts of antimatter and watch how it behaves. Each experiment is like asking the universe to repeat its ancient trick. They have discovered that some particles do behave differently from their antimatter twins. Particles called kaons and b-mesons show tiny preferences that break the perfect symmetry between matter and antimatter. But these differences are still not large enough to explain why matter won so completely. The mystery deepens with each new discovery. Perhaps the answer will come from studying neutrinos. These ghostly particles that pass through your body every second without you feeling them. They might oscillate between matter and antimatter in ways that tip the cosmic scales. Or maybe the answer lies in understanding gravity itself. Einstein showed us that matter and energy curve space and time. Perhaps antimatter curves them differently. Perhaps this difference guided the universe's ancient choice. As you lie here in the darkness, consider this beautiful truth. The atoms in your body are lottery winners. They beat odds of billions to 1. They survived when nearly everything else disappeared into light. Your existence depends on this ancient unfairness. This gentle bias that saved a tiny fraction of matter from annihilation. Without it, the universe would be empty. Just light spreading through expanding space. No stars. No planets. No life. No you. The cosmic magician's greatest trick was not making something disappear. It was allowing something to remain. Something precious and rare. Something that would eventually become conscious and wonder about its own existence. Tonight, as sleep approaches, you can rest knowing you are part of this ongoing mystery. You are matter contemplating its own survival. Atoms that escaped annihilation, now arranged in patterns complex enough to dream. In tomorrow's journey, we will visit the places where humans have learned to recreate this ancient magic, capturing antimatter in bottles made of pure magnetism and discovering why each trapped antiparticle costs more than its weight in precious gems. Imagine walking through a quiet forest at twilight. You carry a jar in your hands, hoping to catch fireflies. But these are no ordinary fireflies. They are made of pure starlight, and they cost more than all the gold ever mined from the earth. This is what scientists do when they hunt for antimatter. Except their jar is not made of glass. It is woven from invisible magnetic fields, as delicate and precise as spider webs made from pure energy. Deep underground, in tunnels that stretch for miles beneath the peaceful countryside, enormous machines hum with quiet power. These are particle accelerators. The most sophisticated antimatter factories humans have ever built. Picture a racetrack, but circular and vast. Particles race around this track at almost the speed of light. They travel in opposite directions, building up incredible energy as they circle again and again. When these speeding particles finally collide, something magical happens. The crash creates a shower of new particles, including precious antimatter. It is like two raindrops colliding and briefly becoming lightning. But creating antimatter is only the first challenge. The harder task is catching it before it disappears. Antimatter particles have no interest in staying around. They want to find regular matter and dance back into light. They are like butterflies that live for only a heartbeat. You must capture them gently, or they will vanish before you can blink. This is where the magnetic bottles come in. Scientists have learned to weave cages from pure magnetism. These invisible prisons can hold antimatter without it ever touching regular matter. The cage works because antimatter particles are electrically charged. They respond to magnetic fields the way iron filings respond to a magnet. The magnetic field guides them in gentle circles, keeping them floating in empty space. Picture a soap bubble floating in the air, held up by invisible currents of wind. Inside this bubble, a single antiproton dances. It spins in tiny loops, never touching the walls of its magnetic prison. Creating even one antiproton requires enormous amounts of energy. The electricity needed could power a small town for an hour. Yet the antiproton itself weighs almost nothing. Less than a speck of dust. Less than a single breath. This makes antimatter the most expensive substance in the universe. A single gram would cost more money than has ever existed on Earth. More than the wealth of all nations combined. Scientists at CERN, the great laboratory beneath the border of France and Switzerland, have spent decades perfecting this art. They create antiprotons one by one. Each one more valuable than a diamond. The antiprotons live in a machine called the antiproton decelerator. This device slows the newborn antiparticles down from nearly light speed to a gentle crawl. Like catching a hummingbird and teaching it to hover motionless in your palm. Once slowed, the antiprotons enter magnetic traps no bigger than a thermos bottle. Inside these tiny prisons, they float in perfect vacuum. Isolated from all regular matter. Suspended in nothingness by invisible magnetic threads. The traps must be perfect. If even a single antiproton touches the wall, it will annihilate instantly. All that time and energy and money vanishes in a flash too small to see. Scientists have learned to keep antiprotons trapped for days. Sometimes weeks. Each day is a victory against the natural desire of antimatter to return to light. But capturing individual antiprotons is only part of the dream. The real goal is to create antiatoms. Complete antimatter versions of hydrogen. Antiprotons orbited by positrons instead of electrons. This requires even more delicate work. Like trying to thread a needle while riding a bicycle in an earthquake. The antiproton and positron must find each other in the magnetic trap and dance together without touching any regular matter. When this finally happens, scientists have created antihydrogen. The simplest antiatom. The antimatter twin of the most common element in the universe. It floats in its magnetic bottle like a tiny star made of shadow. These antiatoms are the rarest objects humans have ever made. Rarer than anything found in nature. Each one exists for only minutes before it touches the trap walls and disappears. But in those brief minutes, scientists can study how antimatter behaves. They shine light on the antiatoms and watch how they respond. They measure their properties with incredible precision. The goal is to answer one of the deepest questions in physics. Does antimatter behave exactly like regular matter? Or are there tiny differences that could explain why our universe chose matter over antimatter? So far, the antimatter seems to follow the same rules as regular matter. Antihydrogen absorbs light at exactly the same wavelengths as regular hydrogen. Its properties mirror those of normal atoms with perfect precision. This is both beautiful and puzzling. If matter and antimatter are truly identical, why did the universe end up with so much more matter? The mystery deepens with each perfect measurement. High above the Earth, space stations conduct their own antimatter experiments. The Alpha Magnetic Spectrometer rides on the International Space Station, watching for antimatter particles in cosmic rays. It searches for signs of antiatoms floating between the stars. If it found even one antihelium nucleus, it would prove that somewhere in the universe, antimatter survived in large amounts. Perhaps entire antimatter stars exist in distant galaxies. So far, the space detector has found only individual antimatter particles. Positrons and antiprotons created by collisions between cosmic rays and interstellar gas. No complex anti-atoms. No signs of antimatter worlds. But the search continues. Every day, the detector analyzes millions of particles streaming in from deep space. Each one might hold a clue to the universe's antimatter mystery. Back on Earth, scientists dream of new applications for their trapped antimatter. Tiny amounts could power spacecraft to distant stars. Antimatter engines would be the most efficient propulsion system possible, turning matter directly into energy. Medical researchers study how antimatter might be used to treat cancer. Beams of antiprotons could destroy tumors with incredible precision, leaving healthy tissue untouched. But these dreams require far more antimatter than we can currently create. To power a spacecraft or treat a patient would need millions of times more antiparticles than have ever been trapped. For now, antimatter remains the universe's most precious substance. More valuable than any treasure, yet so rare it exists only in tiny amounts for brief moments. Each antiparticle floating in its magnetic prison represents humanity's attempt to understand the deepest secrets of existence. Why does anything exist at all? Why did matter win over antimatter? What happened to the universe's missing half? As you drift toward sleep tonight, imagine floating alongside these captured antiparticles in their invisible cages. Feel the gentle pull of magnetic fields holding you suspended in perfect emptiness. You are witnessing humanity's most ambitious treasure hunt, seeking answers written in the language of antimatter itself. But antimatter exists naturally in your own body too, created by the quiet radioactive whispers of certain atoms, and tomorrow we will discover how these tiny messengers of light help doctors see the hidden landscapes within you. Rest your hand on your chest now. Feel the gentle rise and fall of your breathing. Inside your body, a quiet miracle is happening. Antimatter is being born. Not in distant laboratories or cosmic explosions. Right here, in the warm darkness beneath your skin. Tiny messengers of antimatter called positrons are dancing their brief, beautiful dance of existence. These positrons come from a special kind of transformation. Certain atoms in your body are naturally radioactive. They carry too much energy, like overfilled balloons ready to release their excess. One by one, these atoms whisper their energy away. A proton in the nucleus decides to become a neutron. In this gentle change, it releases a positron. A particle of pure antimatter, born from the quiet radioactivity within you. The positron emerges like a butterfly from its cocoon. Perfectly formed. Spinning with the same energy as an electron, but carrying the opposite charge. It is antimatter's gentlest ambassador to the world of matter. But this tiny dancer knows its time is brief. Positrons cannot survive long in a world made of matter. They are strangers here, destined to find an electron partner and return to light. The positron begins its journey through your body. It moves between your cells like a ghost walking through walls. Sometimes it bounces off an atom. Sometimes it curves around the electric fields of nearby particles. Each step of this journey takes the positron further from its birthplace. It might travel a few millimeters through your tissues. In the world of atoms, this is an epic voyage across vast territories of empty space. Then comes the moment of reunion. The positron meets an electron. These perfect opposites recognize each other instantly. Like two dancers who have been searching for their partner across a crowded ballroom. They embrace. In that embrace, both particles cease to exist. Their mass transforms completely into energy. Into light. Two particles of gamma radiation shoot away in opposite directions, carrying the news of this cosmic reunion. This is annihilation at its most gentle. No violence. No destruction. Just a peaceful return to the light from which all particles originally came. Matter and antimatter dancing back into pure energy. This happens in your body thousands of times every second. Tiny flashes of light being born from the marriage of matter and antimatter. You are a soft constellation of these microscopic reunions. But you cannot feel them. Each flash is far too small for your senses to detect. The gamma rays pass through your body like whispers, carrying their light messages into the world beyond your skin. Doctors have learned to listen to these whispers. They use the positrons in your body to see inside you with remarkable clarity. The technique is called PET scanning. Positron emission tomography. They give you a special sugar that has been tagged with radioactive atoms. These atoms will create positrons as they decay. You drink this sugar solution or receive it through a gentle needle in your arm. The radioactive sugar travels through your bloodstream to every part of your body. It flows like a glowing river through your organs and tissues. Places that use more energy absorb more of this special sugar. Your brain, working constantly even as you sleep, drinks deeply from this radioactive stream. Your heart, beating its steady rhythm, glows brightly with positron-creating sugar. Active muscles shine like stars in the PET scanner's view. As the radioactive atoms decay, they release their positron messengers. Each positron finds its electron partner and creates twin gamma rays. These rays of light escape your body and travel to special detectors surrounding you. The detectors catch these gamma rays and trace them back to their source. Like following footprints in reverse, they can pinpoint exactly where each annihilation happened inside your body. Computers weave together millions of these light trails to create a glowing map of your inner landscape. Brain regions thinking hard appear bright with positron activity. Tumors hungry for energy shine like beacons. Organs working properly glow with healthy patterns of light. This is how antimatter helps heal. By becoming light, positrons reveal the hidden geography of health and illness within you. They turn your body into a constellation that doctors can read like a gentle book of stars. The positrons themselves live for only microseconds. Billionths of a second between birth and their dance back into light. Yet in those brief moments, they carry information that can save lives and ease suffering. As you lie here tonight, feel the quiet radioactivity within your bones. Potassium atoms releasing their excess energy. Carbon atoms whispering away their instability. Each decay creates a positron that will soon find its perfect partner. These natural positrons are part of your body's ancient inheritance. The same radioactive elements that power the Earth's core flow gently through your bloodstream. They connect you to the deep fires that warm our planet from within. But most of the positrons in medical scans come from artificial radioactive elements created in particle accelerators. Scientists have learned to make atoms that live for just the right amount of time. Long enough to reach their destination in your body. Short enough to disappear quickly after the scan is complete. The half-life of these medical isotopes is measured in minutes or hours. Like flowers that bloom for a single day, they perform their healing work and then fade away. They leave no trace except the light information they provided. This is the gentle side of nuclear science. Not bombs or power plants, but healing light born from the marriage of matter and antimatter. Positrons carrying messages of hope from the quantum world to the world of human healing. Each PET scan uses antimatter worth millions of dollars if it was sold by the particle. Yet the total amount involved weighs less than a grain of sand. Such is the value and rarity of antimatter, even when it serves the cause of healing. Tonight, as your body rests and repairs itself, positrons continue their ancient dance within you. Born from radioactive whispers, they seek their electron partners in the warm darkness of your tissues. When they find each other, they create light. Gamma rays that carry stories of your body's inner workings. Light that could reveal the health of your organs if captured by the right detectors. But for now, these gamma rays simply escape into the night, carrying their messages to the stars. Part of the cosmic conversation between matter and antimatter that began with the birth of time itself. Tomorrow we will journey far from your peaceful bedroom to discover how this same antimatter dance plays out in the violent theater of thunderstorms, where lightning creates its own brief positron showers in the electric darkness above the sleeping Earth. Listen to the night outside your window. Perhaps rain taps gently on the glass. Maybe wind whispers through the trees. But above these familiar sounds, something invisible is happening. High in the atmosphere, an ancient rain is falling. Not water droplets, but particles from deep space. Cosmic rays that have traveled for millions of years to reach your sleeping world. These cosmic messengers began their journey in the hearts of exploding stars. Supernovas that blazed brighter than entire galaxies before scattering their contents across the void. Each cosmic ray carries the memory of stellar death and rebirth. Most cosmic rays are simple protons. Hydrogen nuclei accelerated to incredible speeds by magnetic fields around distant black holes and neutron stars. They race through space at nearly the speed of light, crossing galaxies like arrows shot from cosmic bows. But hidden among these proton messengers are rare treasures. Antimatter particles. Positrons and antiprotons created in the violent collisions between cosmic rays and interstellar gas clouds. They ride the same stellar winds, carrying antimatter across the galaxy. When cosmic rays reach Earth's atmosphere, they collide with their molecules 20 miles above your head. These collisions create showers of new particles that cascade downward like invisible waterfalls. Some of these particles are antimatter. Positrons born from the cosmic ray collisions, tumbling through the atmosphere toward the sleeping Earth below. Most will annihilate with electrons before reaching the ground, creating brief flashes of gamma-ray light. You rest beneath this gentle antimatter rain every night. Particles that began their existence in distant star explosions finally end their cosmic journey in the air above your bedroom. Their annihilation light passes harmlessly through your roof and walls. But sometimes, the night sky creates its own antimatter in even more dramatic fashion. When thunderclouds build and lightning prepares to strike, the atmosphere becomes a natural particle accelerator. Picture a thundercloud as a massive battery floating in the sky. Electric charges separate within the churning storm. Positive charges rise to the cloud's top. Negative charges sink to its base. The difference in charge builds like water behind a dam. When lightning finally breaks free, it carries enormous electrical current. Billions of volts discharge in microseconds. The lightning channel becomes hotter than the surface of the sun. In this electric furnace, amazing things happen. The intense electric fields accelerate electrons to incredible speeds. These speeding electrons slam into air molecules with such force that they create new particles. Among these newborn particles are positrons. Antimatter children of lightning's electric fury. Scientists have detected these lightning positrons using satellites and high-altitude balloons. Each thunderstorm briefly becomes an antimatter factory, creating positrons in the electric chaos of lightning strikes. The lightning positrons live for only moments. They quickly find electron partners in the storm-charged air and annihilate in flashes of gamma-ray light. These gamma-ray bursts from thunderstorms can be seen from space, marking each storm as a brief beacon of matter-antimatter reunion. But lightning creates more than just positrons. In the most powerful strikes, the electric fields become so intense that they tear apart the very fabric of space itself. They create what scientists call terrestrial gamma-ray flashes. These gamma-ray bursts are among the most energetic events on Earth. They rival the gamma rays from distant black holes and neutron stars. For a brief moment, your planet's atmosphere outshines cosmic giants millions of light-years away. The gamma rays from lightning are so powerful they can create matter and antimatter pairs directly from pure energy. Photons of light become electrons and positrons in a process called pair production. Energy transforms into matter and antimatter right in the storm clouds above your head. This is Einstein's famous equation in action. E = mc². Energy becoming mass. Light becoming particles. The same process that created matter and antimatter in the early universe now happens in your planet's stormy skies. Even when the night is perfectly clear, cosmic antimatter continues its ancient shower. Every second, cosmic ray positrons pass through your body. Most are moving so fast and are so small that they slip between your atoms like ghosts. A few cosmic ray positrons actually stop in your body. They slow down by bouncing off atoms in your tissues. Eventually they find an electron and annihilate, adding their tiny contribution to the gentle radioactivity that is always part of you. Scientists study these cosmic antimatter visitors using detectors in space and deep underground. The Alpha Magnetic Spectrometer on the International Space Station watches for antimatter in cosmic rays 24 hours a day. So far, it has found mostly individual antimatter particles. Positrons and antiprotons scattered through the cosmic ray stream like rare gems in a river of ordinary stones. But researchers keep searching for something more extraordinary. They hope to find a single antihelium nucleus. This would prove that somewhere in the universe, antimatter survived in large amounts. Perhaps entire antimatter stars exist in distant galaxies, invisible to our matter-based telescopes but detectable by the antimatter they shed into space. Deep underground, other detectors wait patiently in abandoned mines and tunnels. Protected from cosmic rays by miles of rock, they search for different antimatter signals. They look for the products of dark matter annihilation, the hypothetical particles that might make up most of the universe's missing mass. If dark matter particles occasionally annihilate each other, they might produce positrons and antiprotons. These antimatter signals would reveal the presence of invisible matter that surrounds every galaxy but interacts only weakly with the matter we can see. The search continues in laboratories around the world. Scientists create antimatter in particle accelerators and study how it behaves. They measure its properties with incredible precision, looking for any tiny difference between matter and antimatter that might explain why our universe chose one over the other. Each measurement confirms what theory predicts. Antimatter follows the same laws as regular matter. It falls down in gravity fields the same way. It absorbs and emits light at identical wavelengths. The perfect symmetry between matter and antimatter remains unbroken in every test. Yet the mystery deepens. If matter and antimatter are truly identical, why does matter dominate the universe? What broke the perfect balance in those first moments after the Big Bang? The answers may lie hidden in the cosmic antimatter rain that falls constantly around you. As you drift toward deeper sleep, imagine the antimatter particles passing through your room right now. Positrons from distant supernovas, born in stellar explosions that happened before the Earth formed. They have traveled across the galaxy to visit your quiet bedroom for just an instant. Some carry the signature of their cosmic origins. Iron positrons from the cores of massive stars. Carbon positrons from stellar winds. Oxygen positrons from supernova shock waves. Each one tells a story of stellar life and death written in the language of antimatter. Above your sleeping world, thunderclouds may be gathering in distant places, preparing to birth their own brief antimatter showers in the electric theater of the sky. But even if the night remains perfectly calm, the cosmic antimatter rain continues its ancient fall, connecting your peaceful dreams to the violent birth and death of stars across the cosmos. In our next journey, we will travel to the very heart of our galaxy, where darkness reigns supreme but antimatter fountains spray across thousands of light-years, created by the most mysterious objects in the universe. Close your eyes and imagine floating above your neighborhood on a clear night. You can see the gentle curve of the Milky Way stretching across the sky like a river of stars. Follow that stellar river with your mind. Let it carry you toward its source. 26,000 light-years away, at the very center of our galaxy, something extraordinary waits in the darkness. A place where space and time bend like soft clay in invisible hands. Where matter transforms into antimatter through the most violent and beautiful processes in the universe. At the galactic center lies a black hole 4,000,000 times more massive than our Sun. Scientists call it Sagittarius A star. But you can think of it as the galaxy's heart. A heart that beats not with blood, but with pure gravitational power. This black hole is invisible to your eyes. It swallows light itself, creating a sphere of perfect darkness in the bright center of the galaxy. Yet around this darkness, the most spectacular antimatter factory in the Milky Way operates with quiet majesty. Picture a cosmic whirlpool. Matter spirals inward toward the black hole like water circling a drain. But this is no ordinary whirlpool. The matter falling toward the black hole moves at a significant fraction of light speed. Friction heats it to billions of degrees. At these incredible temperatures, matter enters a state called plasma. Electrons tear free from their atomic nuclei. The plasma glows brighter than 1,000,000 suns. Yet most of this light is trapped by the thick clouds of dust that surround the galactic center. But the black hole does more than just heat matter. Its immense gravity stretches space itself. Time slows down near the event horizon, the boundary where even light cannot escape. In this twisted realm of space and time, extraordinary things happen. Magnetic fields, carried by the infalling matter, become concentrated and twisted. They form invisible ropes of magnetic force that spiral around the black hole. These magnetic field lines act like cosmic particle accelerators, speeding up electrons and protons to incredible energies. When these ultra-high energy particles collide with lower energy photons of light, something magical occurs. The collision creates pairs of particles, an electron and a positron. Matter and antimatter born from pure energy in the twisted space around the black hole. This process happens countless times every second. The region around Sagittarius A star becomes a nursery for antimatter creation. Positrons stream away from the black hole in all directions, riding the magnetic field lines like invisible highways through space. But the black hole creates more than just individual antimatter particles. Sometimes, when conditions are perfect, it launches enormous jets of matter and antimatter. These jets stretch for thousands of light-years across the galaxy. They are among the largest structures ever created by a single object. The jets form when magnetic field lines become so twisted and concentrated that they snap like rubber bands. The stored magnetic energy launches streams of particles at nearly the speed of light. These streams carry both matter and antimatter far from their black hole birthplace. Imagine garden sprinklers, but made of pure energy and stretching across distances that would take light millennia to cross. The antimatter in these jets travels through space for millions of years before finally encountering regular matter and annihilating in distant regions of the galaxy. Space telescopes can detect the gamma-ray light from these antimatter annihilations. They map the invisible fountains of positrons flowing away from the galactic center. The pattern they reveal is beautiful and complex. Streams and bubbles of antimatter flowing through space like cosmic weather systems. One of the most remarkable discoveries is the existence of antimatter bubbles above and below the galactic center. These vast structures, each spanning 25,000 light-years, are filled with positrons created by the central black hole and other energetic processes. The bubbles rise slowly from the galactic disk like cosmic soap bubbles blown by an invisible giant. They carry antimatter high above the ordinary matter of the galaxy, where it can survive for millions of years before finding electrons to annihilate with. You rest now in one of the spiral arms of this galaxy, far from the violent center where antimatter streams through space. But even here, 26,000 light-years away, you can detect the influence of the distant antimatter factory. Some of the cosmic rays that shower your planet every day began their journey in the galactic center. They were accelerated by the same magnetic fields that create antimatter around the central black hole. They carry the signature of their violent birth across the galaxy to your peaceful world. Other galaxies have similar antimatter factories at their centers. Nearly every large galaxy harbors a supermassive black hole surrounded by swirling matter and magnetic fields. Each one creates its own streams and jets of antimatter that flow through intergalactic space. When these antimatter jets from different galaxies meet in the void between star systems, they create some of the most energetic events in the universe. The collision between matter and antimatter from distant black holes produces gamma-ray bursts that can be seen from billions of light-years away. But most of the time, the antimatter production around black holes is a gentle, steady process. Like a cosmic fountain that has been running for billions of years. The black hole at the center of our galaxy has been creating antimatter since before the solar system formed. This antimatter carries information about conditions near the black hole. By studying the energy and distribution of positrons flowing from the galactic center, scientists can learn about the invisible processes happening in that distant realm of twisted space and time. They discover that the black hole is not just a destroyer of matter. It is also a creator. It transforms ordinary matter into the most exotic forms of energy and antimatter. It recycles the galaxy's contents, turning stars and gas clouds into high-energy particles and radiation. The antimatter created by our galaxy's central black hole will outlive most of the stars you can see in the night sky. Long after the Sun has died and the Earth has been consumed, positrons will still be streaming away from Sagittarius A star, carrying the memory of our solar system's era into the far future. Some of these positrons may eventually travel beyond our galaxy entirely. They could cross the void to other galaxies, carrying antimatter created in the Milky Way to distant cosmic shores. In this way, galaxies share their antimatter across the universe, connecting every corner of space with streams of annihilating particles. As you drift deeper into sleep, imagine following one of these antimatter streams. You ride a positron created moments ago in the twisted space around the galactic center. You travel at nearly light speed through the warm darkness between stars, part of an invisible river of antimatter flowing through the cosmic night. Your positron companion has traveled for thousands of years to reach this part of the galaxy. It carries within its spin and energy the signature of its violent birth near the black hole. It has seen the galaxy from perspectives no human eye will ever witness. Eventually, your positron will meet an electron somewhere in the galactic disk. They will dance together for a microsecond before transforming into pure light. Two gamma-ray photons will shoot away in opposite directions, carrying the news of this reunion to distant corners of space. But tonight, you simply ride the antimatter stream through the peaceful darkness, feeling the galaxy's slow rotation carrying you around the invisible heart where space and time bend like water and antimatter fountains reach toward the stars. In tomorrow's dream, we will imagine ships powered by the perfect marriage of matter and antimatter, carrying human consciousness across the vast distances between stars on beams of controlled annihilation light. Imagine floating in a spacecraft unlike any ever built. The walls around you hum with quiet energy. Through the transparent dome above your head, stars shine with crystal clarity in the endless night of space. Behind you, an engine glows with the most perfect light in the universe. Not the orange fire of chemical rockets or the blue plasma of ion drives. This light is pure white. The color of matter and antimatter dancing back into the energy from which they came. Your ship rides on a beam of controlled annihilation. The most efficient engine possible in our universe. Every particle of fuel becomes energy. Every gram of matter paired with its antimatter twin transforms completely into light. No other engine comes close to this perfection. Chemical rockets waste most of their fuel as heat and exhaust. Nuclear rockets are better, but still convert less than 1% of their mass into useful energy. Only antimatter engines achieve perfect efficiency. The fuel tanks of your starship contain the most precious cargo ever assembled. Equal amounts of hydrogen and antihydrogen, kept apart by invisible magnetic bottles. Each particle of antimatter worth more than gold, more than diamonds, more than any treasure ever mined from Earth. But here in this dream of tomorrow, antimatter has become as common as water. Vast factories in space create it by the kilogram. Solar collectors the size of continents focus starlight into particle accelerators that birth antiprotons by the billion. The antimatter floats in its magnetic prisons like captured starlight. Antihydrogen atoms spinning in perfect isolation, never touching the walls of their electromagnetic cages. Each one waiting for its moment to reunite with regular matter in the engine's glowing heart. When you command the ship to accelerate, magnetic fields guide streams of hydrogen and antihydrogen into the reaction chamber. They meet in the center like two rivers joining to become light. The annihilation happens instantly. Perfect matter meets perfect antimatter. Both cease to exist. In their place, pure energy erupts as gamma rays traveling at light speed. The most concentrated release of energy possible in nature. But gamma rays cannot push your ship directly. They must be transformed into something useful. Mirrors made of exotic materials capture the gamma ray light and convert it into charged particles. These particles stream from the engine nozzle, creating thrust that accelerates your ship toward the stars. Feel the gentle pressure as your vessel begins to move. Not the violent shaking of chemical rockets, but a smooth, constant acceleration. Like being carried by invisible hands through the cosmic darkness. Your antimatter engine can accelerate for months without stopping. It carries enough fuel to reach speeds that would make the journey to nearby stars possible within a human lifetime. Alpha Centauri, for light years away, becomes reachable in just a few decades of travel. As your ship gains speed, strange things begin to happen. Einstein's relativity reveals itself in the growing distortion of space and time around you. The stars ahead shift to blue as their light is compressed by your motion. The stars behind fade to red as their light stretches. At 10% of light speed, your ship covers the distance from Earth to the Moon in just 14 seconds. The entire solar system becomes small and intimate. Jupiter's moons pass like stepping stones. The outer planets slide by like distant lighthouses in the cosmic night. But this is still not the limit of what antimatter engines might achieve. With enough fuel and time, your ship could accelerate to half the speed of light. At these velocities, the universe begins to reveal its hidden nature. Time aboard your ship slows compared to the rest of the universe. The months and years of your journey pass normally for you, but decades flow by on Earth. This is the gift of relativity. It makes the vast cosmos accessible to mortal beings with finite lifetimes. Your antimatter engine burns with perfect efficiency for years. Each kilogram of fuel propels your ship farther from home and deeper into the unknown. The interstellar medium streams past your hull like a river of atoms and dust. Between the stars, space is not empty. It contains wisps of hydrogen gas, grains of cosmic dust, and the ancient light of the cosmic microwave background. Your ship moves through this tenuous medium like a whale swimming through an ocean of mist. Sometimes you encounter denser clouds of interstellar matter. Your ship's shields glow as they deflect particles moving at relativistic speeds. These same particles would be deadly to an unprotected crew, but your antimatter-powered force fields brush them aside like raindrops. The nearest star system grows brighter ahead of you. What started as a point of light has become a disk, then a sphere, then a blazing sun surrounded by the faint specks of planets. You have crossed the interstellar void, carried by the perfect marriage of matter and antimatter. But antimatter engines offer more than just fast travel between stars. They could make the cosmos truly accessible to human exploration. Fleets of antimatter ships could carry entire civilizations to distant worlds, spreading life throughout the galaxy. These vessels would be cities in space, their hulls enclosing gardens and lakes, forests and mountains. Antimatter engines would provide all the energy needed to maintain perfect environments for thousands of inhabitants during journeys lasting centuries. The ships themselves would become worlds. Children would be born between the stars, growing up with the cosmos as their backyard. They would know the names of distant nebulae as easily as you know the names of nearby cities. Some antimatter ships might never stop at planets at all. They could become permanent nomads, traveling from star to star for thousands of years. Their crews would develop into new branches of humanity, adapted to life in the deep space between worlds. Others might use their antimatter engines to dive close to black holes, using gravity as a slingshot to reach even greater speeds. They could surf the twisted space around these cosmic giants, gaining energy from the very fabric of reality itself. But all of this remains a dream for now. Humanity has created only the tiniest amounts of antimatter in laboratory conditions. The technology to produce, store, and safely use antimatter as fuel lies decades or centuries in the future. The challenges are immense. How do you create antimatter in industrial quantities without consuming more energy than it provides? How do you store something that annihilates instantly when it touches any normal matter? How do you build engines that can survive the perfect efficiency of matter-antimatter annihilation? These questions wait for future generations to answer. Perhaps children being born tonight will grow up to become the engineers and physicists who make antimatter engines real. They will turn these dreams of impossible ships into the vehicles that carry humanity to the stars. For now, you can only imagine floating in such a vessel, feeling the gentle thrust of perfect annihilation carrying you toward distant suns. The antimatter engine behind you burns with the light of creation itself, transforming mass into energy with the same efficiency that powered the Big Bang. In your dream ship, the vast distances between stars shrink to manageable journeys. The galaxy becomes a neighborhood where each star system is just a few years' travel away. Antimatter makes the cosmos intimate and close, bringing the distant stars within reach of human hands and hearts. But even if we never build such engines, the dream itself teaches us something profound about the nature of reality, and tomorrow we will explore why this most perfect fuel commands such an impossible price. Picture holding the most expensive object ever created by human hands. It weighs nothing you can feel. It is smaller than a grain of sand. Yet it costs more than all the gold in every bank vault on Earth. This treasure is a single gram of antimatter. One small teaspoon of antiprotons and positrons floating in perfect magnetic cages. In your imagination tonight, you cradle this invisible fortune with infinite care. The antimatter in your hands contains the energy of 43 million tons of TNT. More explosive power than the largest nuclear weapons ever built. Yet it sits peacefully in its electromagnetic prison, waiting with the patience of eternity. But the true wonder is not its power. It is the cost of creating something so impossibly rare. That single gram represents the entire economic output of a large nation for several years. Trillions upon trillions of dollars transformed into particles you cannot see. Every antiproton in your teaspoon required enormous amounts of electricity to create. Power stations burning coal and splitting atoms worked for months to generate enough energy for particle accelerators to birth these antimatter twins. At CERN, the great laboratory beneath Europe, it takes 10 billion times more energy to create an antiproton than the antiproton itself contains. Like using a waterfall to fill a single drop. The process is staggeringly inefficient by any normal measure. Yet scientists continue this work with dedication bordering on love. Each antiproton they capture is a small victory against the natural order. A tiny rebellion against the universe's preference for matter over antimatter. The antiproton decelerator, one of the most sophisticated machines ever built, creates perhaps 1 billion antiprotons per second when it operates. This sounds like a vast number. But 1 billion antiprotons together weigh less than a single virus. If you ran this machine constantly for 1,000,000 years, it would create about 1 gram of antimatter. The same amount you now hold in your imagination. The machine would consume more electricity than humanity has ever generated in its entire history. This is why antimatter remains the most expensive substance in the universe. Not just expensive compared to gold or diamonds. Expensive beyond any earthly comparison. A currency so valuable that nations could not afford to buy even microscopic amounts. The production process itself is a marvel of precision engineering. First, protons are accelerated to nearly light speed in vast circular tracks underground. These speeding protons crash into metal targets, creating showers of exotic particles. Among these particle children are antiprotons. But they emerge moving at tremendous speeds, far too fast to capture. They must be slowed down delicately, like catching butterflies with nets made of pure magnetism. The antiprotons enter a series of electromagnetic rings that gradually reduce their speed. Each ring is cooled to temperatures colder than deep space. Superconducting magnets create perfect magnetic fields that guide the antiprotons in precise circles. Hours of careful deceleration bring the antiprotons to speeds slow enough for magnetic traps to hold them. They float in ultra-high vacuum chambers, isolated from all normal matter by invisible walls of electromagnetic force. Even storing antimatter requires technologies that push the boundaries of human engineering. The magnetic bottles must be perfect. If a single antiproton touches the wall, it vanishes in a flash too small to see, taking with it millions of dollars worth of energy. The storage systems operate at temperatures approaching absolute zero. Cryogenic systems keep the superconducting magnets cold enough to create perfect magnetic fields. Vacuum pumps remove every trace of normal matter from the storage chambers. Backup power systems ensure the magnetic fields never fail. If the electricity stops for even a moment, the antimatter escapes its cage and annihilates instantly. Months of work and millions of dollars disappear in microseconds. Scientists have learned to store antiprotons for weeks or even months. Each day the antimatter survives in captivity is a small miracle of engineering precision. The delicate balance between creation and annihilation maintained by human skill and technology. But weeks or months is nothing compared to the cosmic timescales on which antimatter naturally exists. In the depths of space, antiprotons created by cosmic ray collisions can survive for millions of years before finding electrons to annihilate with. The antimatter you hold in your imagination might have cost $1 trillion to create. But in space, natural processes create the same amount for free every day. Cosmic ray collisions, black hole jets, and stellar explosions scatter antimatter throughout the galaxy without regard for economic cost. This paradox highlights the difference between human technology and cosmic processes. What costs us unimaginable wealth, the universe creates casually as a byproduct of ordinary stellar violence. Yet even cosmic antimatter is precious in its own way. Each positron created in a distant supernova carries information about conditions in that stellar explosion. Each antiproton accelerated by a black hole tells us about the magnetic fields in those twisted regions of space. The high cost of artificial antimatter has led scientists to search for more efficient production methods. Some propose using laser beams to create matter-antimatter pairs directly from light. Others suggest mining antimatter from the radiation belts around planets. Fusion reactors might one day create antiprotons as a byproduct of nuclear reactions. Solar collectors in space could focus starlight to create antimatter through photon collisions. These remain dreams, but dreams with mathematical foundations. The economic challenge of antimatter production has also inspired new applications for tiny amounts. Medical procedures use positrons worth thousands of dollars per dose. Research experiments make do with just a few thousand antiprotons at a time. Each antiproton in a physics experiment represents not just scientific curiosity, but significant financial investment. Universities and research institutions spend millions of dollars to answer basic questions about the nature of antimatter. Is antimatter affected by gravity the same way as normal matter? Do antihydrogen atoms absorb light at exactly the same wavelengths as regular hydrogen? These questions require antimatter so expensive that each measurement costs more than luxury cars. Yet the answers matter profoundly. If antimatter behaves even slightly differently from regular matter, it could explain why the universe contains more matter than antimatter. The cosmic mystery that allows your existence might be solved by studying the most expensive particles ever created. Private companies have begun investing in antimatter research, hoping to find commercial applications that could justify the enormous costs. Antimatter-powered spacecraft engines remain decades away, but the potential profits from interplanetary travel motivate continued investment. The dream of cheap antimatter production drives research into exotic physics. Scientists study whether dark matter might naturally decay into antimatter. They search for cosmic strings that could produce matter-antimatter pairs. They investigate whether extra dimensions might contain hidden antimatter sources. As you hold this imaginary fortune in your hands, consider the human dedication required to create it. Thousands of scientists and engineers working for decades to capture particles that exist for mere moments. The transformation of entire power grids into microscopic amounts of the universe's most perfect fuel. The antimatter floating in your mental grasp represents humanity's boldest attempt to harness the fundamental forces of creation. Each antiproton is a small piece of the Big Bang, recreated through human ingenuity and incredible expense. In tomorrow's exploration, we will discover how this impossibly expensive substance fits into the universe's deeper architecture, where every particle must have its perfect opposite to maintain the cosmic balance that allows anything to exist at all. Imagine the universe as a vast library where every book must have its perfect opposite. For each story written in the language of matter, there exists another story written in antimatter's script. Together, they balance the cosmic accounts with mathematical precision. This is the deepest truth about antimatter. It is not just matter's enemy or its fuel. It is matter's other half. The negative to matter's positive. The shadow that gives substance to the light. In the beginning, when energy first learned to become matter, it followed rules as strict as any law of mathematics. Energy can create a particle, but only if it also creates that particle's antiparticle twin. The universe's books must always balance. Picture a cosmic accountant keeping perfect records. Every electron born must be matched by a positron. Every proton requires an antiproton. Every neutron needs its antineutron. The ledger of existence always adds up to zero. This balance runs deeper than the particles themselves. It touches the fundamental forces that shape reality. Electric charge must balance perfectly. For every positive charge created, nature demands an equal negative charge somewhere else. Even more mysterious quantities follow the same rule. Baryon number, lepton number, strangeness, charm. These are the hidden currencies of particle physics. Nature counts them all with perfect precision, ensuring that creation never breaks the cosmic bank. You are part of this ancient accounting system. Every proton in your body carries a positive charge that must be balanced by electrons spinning in atomic orbits. Your very existence depends on this electrical neutrality that antimatter helps maintain. The balance extends beyond individual atoms to the structure of matter itself. The strong force that holds atomic nuclei together works through particles called gluons. These force carriers also have antiparticle twins, creating a symmetry in the very glue that binds matter. Photons, the particles of light, are their own antiparticles. They represent perfect balance made manifest. When matter and antimatter annihilate, they become photons. Light is the neutral currency into which all cosmic debts ultimately resolve. This symmetry between matter and antimatter reveals something profound about the nature of existence. Reality is not a solid foundation but a temporary arrangement of balanced opposites. You are not permanent matter but a brief constellation of energy temporarily organized into conscious form. The emptiness of space itself participates in this balance. What seems like vacuum actually seethes with virtual particles popping in and out of existence. Electron-positron pairs borrow energy from the quantum void, exist for microscopic moments, then pay back their debt by annihilating. These virtual particles cannot be observed directly, but their effects are real. They create tiny shifts in the energy levels of atoms. They generate forces between parallel plates in empty space. The vacuum itself is alive with the constant dance of matter and antimatter twins. Even black holes obey the laws of balance. Stephen Hawking showed that these cosmic giants slowly evaporate by creating particle pairs at their event horizons. One particle falls into the black hole while its antiparticle twin escapes as radiation. The black hole loses mass equal to the energy of the escaping particles. This Hawking radiation means that black holes are not eternal. They slowly return their stolen matter to the universe in the form of balanced particle pairs. Even the most massive objects must eventually settle their cosmic debts through the antimatter balance. The symmetry extends to the largest scales of space and time. If the universe is infinite, then somewhere in the vast cosmos there might be regions dominated by antimatter instead of matter. Entire antigalaxies where antilight shines from antistars onto antiplanets orbiting in antimatter solar systems. These antimatter domains would be perfect mirror images of our own region of space. Anti-people living anti-lives, thinking anti-thoughts that mirror our own experiences. To them, we would be the antimatter universe, made of exotic particles that annihilate with their normal matter. The boundary between matter and antimatter domains would be marked by spectacular annihilation events. Gamma-ray beams stretching across millions of light-years, marking the places where matter and antimatter meet and return to light. These cosmic battle lines might be detectable by future telescopes. But closer to home, the balance plays out in gentler ways. The cosmic microwave background radiation that fills all space carries the faint signature of ancient matter-antimatter annihilations. This light has been traveling for nearly 14 billion years, carrying the memory of the universe's early balanced state. In your own body, the balance continues moment by moment. Radioactive atoms decay, creating positrons that quickly find electrons and annihilate. Cosmic rays create particle showers that include antimatter, most of which disappears in microscopic flashes of gamma-ray light. The balance is not perfect in our observable universe. Matter won a tiny victory in the cosmic war, leaving us in a cosmos made mostly of ordinary particles. But the ghost of that ancient balance haunts every physical law, every particle interaction, every quantum field that underlies reality. This imperfect balance is what allows complexity to exist. If matter and antimatter had been created in exactly equal amounts, they would have annihilated completely. The universe would contain only light spreading through expanding space. No atoms. No molecules. No stars. No life. The slight excess of matter over antimatter, 1 part in a billion, created everything you see around you. Stars, planets, oceans, forests, cities, and the intricate patterns of your own consciousness. All of existence emerged from this tiny cosmic imbalance. Yet the deeper symmetry remains. The laws of physics still demand that every particle have its antiparticle twin. Every force must have its balanced opposite. Every conservation law must be obeyed with mathematical precision. As you drift toward sleep tonight, you become part of this cosmic balance. Your atoms borrowed their existence from the quantum void billions of years ago. They have been cycling through stars and planets, through ancient seas and living creatures, maintaining their place in the universal ledger. One day, these same atoms will return to the cosmic account. They may be recycled into future stars or scattered through the expanding universe. But they will always carry the memory of the balance from which they came. The antimatter that serves as their cosmic counterpart waits patiently in the quantum fields that underlie all reality, ready to restore perfect balance when the universe finally chooses to close its books and return all matter to the light from which it originally emerged. Until then, you rest in the gentle embrace of this cosmic balance, your consciousness a temporary flowering of the same symmetries that govern the dance of matter and antimatter throughout space and time. Tomorrow we will witness the moment when these perfect opposites meet, creating the brightest and most efficient reaction in all of nature, where Einstein's most famous equation reveals its deepest truth in flashes of pure light. In the quiet darkness of your room, imagine watching the most perfect dance in all of nature. 2 particles approach each other slowly through empty space. One is made of ordinary matter. The other is its antimatter twin, born from the same cosmic energy but spinning in the opposite direction. They are perfect opposites in every way. Same mass, same size, but opposite charge. Like 2 dancers who have been practicing the same routine their entire lives, but one learned it while looking in a mirror. As they draw closer, something beautiful begins to happen. Electric forces pull them together with increasing strength. The positive charge on one particle attracts the negative charge on its twin. They spiral toward each other in an elegant ballet of attraction. This is not a violent collision. There is no crash, no explosion, no destruction. Instead, something far more profound occurs. The 2 particles simply cease to exist. In the place where they met, pure energy appears in the form of light. This is annihilation. The most perfect transformation possible in our universe. 100% of the particle's mass becomes energy. No waste. No byproducts. No inefficiency. Just the complete conversion of matter into light, exactly as Einstein's famous equation describes. E equals mc squared. Energy equals mass times the speed of light, squared. This simple equation contains the secret of why antimatter is so precious. It reveals that even tiny amounts of mass contain enormous quantities of energy when multiplied by the speed of light twice. When an electron meets a positron, their combined mass is incredibly small. Less than the weight of a single atom. Yet their annihilation produces gamma rays with energy equivalent to millions of volts of electricity. The speed of light squared is such an enormous number that even microscopic masses become significant sources of energy. Picture two soap bubbles floating toward each other in still air. When they touch, they merge and disappear, leaving behind only a brief shimmer in the light. Particle annihilation is like this, but instead of air and soap film, the bubbles are made of concentrated energy, and instead of a shimmer, they leave behind photons of pure light. The gamma rays created by annihilation are the highest energy forms of light in the electromagnetic spectrum. They carry far more energy than visible light, more than ultraviolet or X-rays. They are packets of pure energy traveling at light speed, carrying the news of the particles' reunion to distant corners of space. These gamma rays always appear in pairs, shooting away from the annihilation point in exactly opposite directions. This preserves the law of conservation of momentum. The original particles had equal and opposite momentum, so their light children must also balance perfectly, racing away from each other through space. This happens millions of times every second in your own body. Positrons created by natural radioactivity find electrons in your tissues and annihilate peacefully. Each reunion creates twin gamma rays that pass through your body and escape into the world beyond your skin. You cannot feel these microscopic annihilations. They are far too small for your senses to detect. But medical scanners can listen to their light whispers and use them to create detailed images of your inner landscape. In PET scanners, doctors give you sugar tagged with radioactive atoms that create positrons. As these positrons find electrons throughout your body, they create paired gamma rays that travel in straight lines to detectors surrounding you. Computers trace these light paths backward to pinpoint exactly where each annihilation occurred. The resulting image is like a constellation map of your body's energy use. Brain regions thinking hard glow brightly with annihilation light. Heart muscle pumping blood creates steady patterns of gamma ray pairs. Tumors hungry for energy shine like beacons in the antimatter starlight. But medical imaging represents just one small application of this perfect reaction. In cosmic ray showers high above your head, antiprotons and positrons from distant stars meet electrons and protons in Earth's atmosphere. Their annihilations create cascades of gamma rays that rain down through the night sky. Scientists use ground-based detectors to catch these cosmic gamma rays and trace them back to their sources. Each photon carries information about the antimatter that created it, revealing the presence of black holes, neutron stars, and other exotic objects scattered throughout the galaxy. Sometimes, entire antimatter atoms meet their matter twins in space. When antihydrogen encounters regular hydrogen in the thin gas between stars, both atoms disappear completely. Their annihilation creates not just gamma rays, but also showers of other particles as protons, antiprotons, electrons, and positrons all find their opposites simultaneously. These complex annihilation events release tremendous amounts of energy in tiny volumes of space. For brief moments, the temperature at the annihilation point exceeds that of stellar cores. Yet the total energy involved is so small that the flash passes unnoticed except by the most sensitive detectors. The perfect efficiency of matter-antimatter annihilation makes it the ultimate energy source for future technologies. Chemical reactions release only a tiny fraction of their mass as energy. Nuclear fusion converts less than 1% of fuel mass into useful power. Only antimatter achieves complete conversion, turning mass directly into energy with perfect efficiency. This efficiency comes from the fundamental nature of particles and antiparticles as exact opposites. When they meet, every property cancels out perfectly. Positive charge cancels negative charge. Spin cancels antispin. Matter cancels antimatter. Only energy remains, liberated from the prison of mass. The process works in reverse as well. High-energy photons can spontaneously create matter-antimatter pairs through a process called pair production. Energy becomes mass, following the same equation but in the opposite direction. Light transforms into electrons and positrons when it passes through strong electric fields. This happens naturally near black holes and neutron stars, where powerful magnetic fields accelerate charged particles to incredible energies. The accelerated particles emit gamma rays so energetic that they spontaneously become electron-positron pairs. Energy creates matter and antimatter twins from pure light. You witness this cosmic recycling every day in cosmic ray interactions above your head. High-energy photons from space create antimatter particles in Earth's atmosphere. These particles quickly find matter partners and annihilate back into light. The cycle of energy to energy continues endlessly. The most powerful annihilation events in the universe occur when entire antimatter regions meet matter domains. If such collisions happen somewhere in the vast cosmos, they would create gamma-ray bursts visible from billions of light-years away. Entire antimatter galaxies turning to light in spectacular displays of cosmic annihilation. But even single particle annihilations connect you to these cosmic processes. The positron that annihilates in your body tonight follows the same laws as antimatter created in the hearts of distant quasars. The gamma rays escaping your tissues carry the same energy signature as light from the most violent events in space. Each annihilation, no matter how small, demonstrates the fundamental convertibility of mass and energy. Einstein's equation is not just a mathematical curiosity but a practical recipe for the most efficient reaction possible. Matter and antimatter represent energy in its most concentrated form, waiting to be released through perfect reunion. As you rest in the darkness, feel the gentle annihilations happening within your warm body. Positrons and electrons finding each other in microscopic embrace, transforming their borrowed existence back into the light from which all particles originally came. These tiny stars, born and dying in an instant, remind you that you are not separate from the cosmic processes that govern distant galaxies. The same perfect reactions that power quasars and gamma-ray bursts illuminate your dreams with their gentle, healing light. And in our final journey together, we will discover how all matter yearns for this perfect reunion, this ultimate dance back into pure energy, as we explore the eternal return to light that awaits every particle in the universe. Your breathing grows slower now. Deeper. Each breath carries you further into the gentle darkness where dreams begin. But before sleep takes you completely, rest in this final truth about antimatter and the cosmic story it tells. You are made of ancient light. Every atom in your body began as pure energy in the first moments after the Big Bang. That primordial light learned to become matter through the universe's patient alchemy. It condensed into particles, formed the first atoms, and eventually found its way into your bones and blood. But light remembers its origins. Deep in the quantum heart of every particle lies the memory of the pure energy from which it came. Matter carries within itself a longing to return to that original state of perfect brightness. Antimatter is the key to this return journey. When matter meets its perfect opposite, both remember what they once were. They release themselves from the bonds of mass and spin back into the light that gave them birth. This is not destruction but homecoming. In your body tonight, this ancient reunion plays out in microscopic whispers. Positrons created by radioactive decay find their electron partners and transform back into gamma-ray light. Each tiny annihilation is a spark of the original cosmic fire, briefly rekindled in the warm darkness of your tissues. These photons of annihilation light carry forward the memory of matter's journey. They have witnessed the birth of particles in the early universe. They have traveled through the hearts of dying stars. They have crossed vast gulfs of space to participate in the quiet radioactivity that warms your sleeping body. When these gamma rays escape your skin and travel into the night, they join the ancient conversation of light that fills all space. The cosmic microwave background radiation. The afterglow of creation itself. The gentle whisper that has been telling the universe's story for nearly 14 billion years. Someday, far in the future, all matter may return to light in this way. The universe will expand and cool until only the longest-lived particles remain. Protons themselves may decay, releasing their energy back into the cosmic sea of photons. Even black holes will evaporate through Hawking radiation, transforming their captured matter into streams of light. In that distant future, antimatter will play its final role as cosmic redeemer. If any antimatter survives in hidden corners of the universe, it will serve as the catalyst for matter's ultimate transformation. Particle by particle, the physical universe will return to the pure energy from which it emerged. But this ending is also a beginning. Energy can always become matter again when conditions are right. In the far future, quantum fluctuations might spontaneously create new particle pairs from the vacuum. Matter and antimatter twins born from pure nothingness, beginning the cosmic cycle anew. Perhaps this has happened before. Perhaps our universe is just one chapter in an eternal story of energy becoming matter, matter finding antimatter, and both returning to light. An endless dance of creation and reunion, playing out across infinite time and space. You participate in this dance even as you sleep. Your atoms exchange energy constantly with the environment around you. Photons from your warm skin carry thermal radiation into the cool night air. Your body glows softly in the infrared spectrum, painting your bedroom with invisible light. This gentle glow connects you to the stars visible through your window. They too shine by converting matter into energy, though through the slower process of nuclear fusion. Your body's warmth and stellar fire both spring from the same source. The energy locked within matter since the universe began. The antimatter created in cosmic ray showers above your head follows its own path toward light. Most positrons and antiprotons find matter partners within minutes of their creation. They annihilate in brief flashes of gamma radiation that add to the subtle background glow illuminating the cosmos. Even the antimatter trapped in laboratories around the world yearns for this return. The antiprotons floating in their magnetic cages at CERN carry within their quantum structure the same longing for reunion. They wait patiently in their electromagnetic prisons, dreaming of the electron partners they have never met. When scientists finally allow these laboratory antiparticles to meet ordinary matter, they witness the universe's most fundamental process. The return of borrowed energy to its source. The completion of a journey that began with the first light of creation and ends with new light born from perfect reunion. This is why antimatter moves us so deeply. It represents not just exotic physics or potential technology, but the promise of completion. The assurance that every particle will eventually find its way home to the light from which it came. In your dreams tonight, you might imagine riding alongside a positron on its brief journey through your body. Feel the electric attraction drawing it toward its electron partner. Experience the moment of recognition when matter meets antimatter and both remember their shared origin in cosmic light. Or perhaps you dream of floating in the vast spaces between galaxies, where antimatter streams from distant black holes paint invisible auroras across the cosmic dark. Each annihilation a small star blooming and fading, adding its voice to the ancient song of matter returning to energy. The story of antimatter is ultimately the story of coming home. Every particle in the universe carries within itself the memory of the pure energy from which it emerged. Through billions of years of cosmic evolution, matter has built stars and planets, oceans and forests, bodies and minds capable of wonder. But the deepest wonder is this. All of this magnificent complexity arose from light. And all of it dreams, on some level, of returning to light. Antimatter offers the path for this return. The perfect partner for matter's final dance back into energy. As sleep finally claims your consciousness, let this truth settle gently into your dreams. You are temporarily organized starlight, borrowing form from the cosmic energy that flows through all things. Your atoms will outlive your thoughts will outlive your breath, but the energy that powers both is eternal. When your time comes to return that borrowed light to the universe, antimatter will be waiting. Somewhere in the quantum foam that underlies reality, your perfect opposite particles drift patiently through space and time, carrying the keys to your ultimate transformation back into the eternal glow. Rest now in this cosmic embrace. You are light dreaming it is matter, matter dreaming it is alive, life dreaming it is conscious, consciousness dreaming it is separate from the light. But separation is illusion. Return is inevitable. And the light that awaits your homecoming is the same light that gave you birth among the stars.